Welcome. Today we'll explore enthalpy diagrams and how they help us understand chemical reactions. These diagrams are essential tools for visualizing the energy changes that occur during chemical processes. Let's start by understanding the basic components of an enthalpy diagram. On the vertical axis, we have enthalpy or energy content, usually measured in kilojoules per mole. The horizontal axis represents the progress of the reaction, showing how the reactants transform into products. Let's first look at an exothermic reaction. We start with our reactants at a higher energy level. The products end up at a lower energy level, showing that energy is released during the reaction. The peak represents the activation energy, the energy barrier that must be overcome for the reaction to proceed. This highest point is called the transition state. Now, let's look at an endothermic reaction. Here, the reactants start at a lower energy level. The products end up at a higher energy level, showing that energy is absorbed during the reaction. Again, we see the activation energy barrier, but notice how the overall energy change is positive. Let's compare exothermic and endothermic reactions side by side. Let's look at some real-world examples. Burning fuel is an exothermic reaction. It releases heat energy that we can use. On the other hand, photosynthesis is endothermic. Plants need to absorb energy from sunlight to convert carbon dioxide and water into glucose. Understanding enthalpy diagrams helps us predict and explain chemical reactions. The activation energy tells us how difficult it is to start a reaction, while the overall energy change tells us whether the reaction releases or absorbs energy. This knowledge is crucial in chemistry and has numerous practical applications in industry and everyday life.